Please join me in welcoming Otis Alexander.
So I'm going to really consider getting a wig for myself for my next presentation. Might help with my confidence. Not this time. Either way, so I'm going to give a quick update about ATT&CK for ICS. I'm going to try to cover some of the typical things that I get asked about. So why ATT&CK for ICS? How does it fit into the other frameworks? What are the use cases? And of course, when is it going to be available? So why ATT&CK for ICS? So we can think about it from a couple of different perspectives. ICS, industrial control systems, are behind some of the world's most critical infrastructure. That's a reason in and of itself to kind of look at how adversaries are affecting these systems. The other thing is asset owners and defenders really want to have a deep knowledge about how adversaries are affecting these systems. They want to know about their tradecraft. They want to know about the technologies they use, and they want to use that to help inform their defenses. Another thing is adversaries have unique behaviors in these environments. The environments are unique in and of themselves, and I'll go over a couple of the things that we have to consider. So unique adversary goals. So one of the things that adversaries are trying to do in this area, they're trying to disrupt some delivery of service in conjunction with the industrial process. They may also try to cause physical damage to pieces of equipment, so that's important as well. And some of the things that we really don't want to happen are the really catastrophic failures. So things that affect property or human life. Some other things that we have to consider are the technological differences between ICS and maybe traditional IT systems. While IT is present in ICS, we also have things like controllers that are interfacing directly with big pieces of equipment that run the process. We also have specialized applications and specialized protocols, and these things are taking into account the state of the industrial control system at any point in time, and they're allowing us to make changes to the system. So these are all important things that we have to take into consideration. Then there's different ways of defending these systems. So we're less mature in this area. So one thing is, what are the data sources that we need in order to defend these systems? Where do we collect them from? If we're dealing with low-level embedded controllers, they don't have the same interfaces to collect host-based information. We also have to think about the protocols. And the last thing I want to highlight is, if we're thinking about mitigations or security controls, we don't want them to affect safety. We really don't want to be a part of the problem. So these are a lot of unique considerations that we have, and I think this is kind of the why we want an ATT&CK for ICS. So in general, when we're thinking about industrial control systems, we have to think kind of from the asset owner or operator's perspective and what their complete system looks like. So this is just a representation of the functional levels of an asset owner's system. What this includes is what you would traditionally call like a headquarters or something like that, like enterprise systems, high-level operations management. And then you get down into the OT, or operational technology, or industrial control system, where you have supervisory control, some remote way of looking into the system, controlling the system, and then some local control that you may have that directly interfaces with the pieces of equipment. So looking at the traditional adversary behavior, it kind of ranges along the whole model here. So it's not like adversaries are always just getting into supervisory control or the low-level system. They're sometimes, or most of the times, making their way through from the enterprise systems down. So IT literally spans the whole model. It spans from enterprise systems all the way down to basic control sometimes, where you have embedded windows and things like that. So that's where enterprise attack really comes into play, because it explains the entry points for adversaries coming in via IT or enterprise systems. It also explains that IT conduit that they leverage to get up into basic control or to the area they need to be in the industrial control systems. But we can't forget about the special goals that adversaries have at the low levels, what they're really trying to accomplish. We can't forget that there are protocols that are unique. There's unique platforms at the bottom. There are embedded systems that interface with the system, with the equipment. And we can't forget that there's specialized applications that operators use. And that's really where Attack for ICS comes into play. So that's its focus, is to complete the story of the adversary's behavior from enterprise all the way down to the low-level systems. So what we're doing is we're really trying to figure out what the interface between the two models are. And we have some solutions, but we're trying to refine that so that you can get the full gamut of adversary behavior in these systems. So what are some of our use cases? So we have some current ones that we are working on now that we're currently utilizing, but we also have some future ones that we want to look at. So in general, we utilize a lot of the same use cases as enterprise. So one of the big ones is standardized information reporting. So we have so many reports for the same incident that report in different ways. And sometimes it's hard to get a sense of what people missed and what's common. So a standard language for looking at these reports, or if security practitioners use a standard language to report out, may help the community. A lot of our use cases center around the analysts as well. So enabling the analysts to do their job better. This is still kind of a new area. When we talk about OT SOCs, they're having a hard time finding people who have the expertise in this area. So Attack for ICS can help them in their job. So one thing is hunt and incident response playbooks, analytic development, analyst training. Also, we utilize adversary emulation or threat-based red teaming in testbed environments to better understand what the artifacts are that are left behind by adversaries, to understand how well our defenses are doing, and things like that. Another use case is criticality analysis. So when we're looking at an industrial control system, we can better understand how assets and functions link up to the mission, and how an adversary utilizing certain techniques and procedures can interrupt those functions or those assets. So we can better get a sense of what we need to focus on in the environment that affects the mission. So a future use case that we're really interested in is threat modeling at the design phase. So we've been talking to device manufacturers, and one of their critical needs, and one of the things that they've been using Attack for ICS for, is to help untrained engineers understand what the ramifications are of adding features at the design process for low-level embedded controllers. So they can understand what attack vectors are opening up, what are the TTPs associated with that, and then what mitigations and security controls they can use to kind of address those things. So challenges. We've had a lot of challenges in terms of working with this framework, building this framework, and one of them is just a general lack of real-world data. There's some really good stuff out there. There's some detailed information that we're able to capitalize on for this framework. But in general, I mean, our lights are on. We don't have problems with water. You know, in general, things seem stable. So it doesn't seem like there's a lot going on. And that could be for a number of reasons. Maybe nothing's happening. Maybe we have no visibility and we don't know what's happening. Maybe we're really bad at root cause analysis. So what is actually an attack, we chop up to a fault or human error. Or maybe we're just really bad at information sharing, or we don't have any incentive to share information. So we hope the attack model for ICS will help with some of this, to get people talking more about what they're seeing in their environments, and also to start to think about visibility in these environments so that we do catch what's going on. Also, a big thing is, what's the proper level of abstraction when you're dealing with multiple domains? We look at electric power, we look at water systems, oil and gas. What level should the techniques be at to best explain adversary behavior over a broad set of domains? And then diverse set of protocols and vendors. How do we find the proper abstraction layer? And we've been getting feedback about that to help out. And then scope. So do we just focus on adversaries and what they've done to certain domains, do we expand that out to think about how these TTP affect different domains? Do we look at the whole cyber physical system domain in general? Any cyber element that affects the physical world, is that how far do we want to go, or do we kind of scope it and be more refined? These are all challenges that we have thought about, that we're addressing with the framework. So we've gotten a lot of good feedback, and that's helped us in terms of our tactic development. So we've included some new tactic categories that we think are really important to describing adversary behavior. Initial access is one. We want to know how the adversaries are making their way into OT environments. We want to know how they're inhibiting or response functions. So that's deals with safety, protection, quality assurance, and the like. Because these are all protection mechanisms that should be in place to stop bad things from happening. And then how adversaries impair process control. So how do they disable, manipulate physical processes to cause some ultimate impact, like loss of control, loss of view, or loss of revenue or productivity. So these are all things that we're considering. We've updated the attack matrix to reflect some of these new tactics, and we've added techniques to address how adversaries are actually accomplishing these goals. So some things that people ask me first, I'm gonna address now. So what's the status of attack for ICS? Well, we're currently in our third major revision, and I was trying to kind of highlight some of the changes that we made in this last revision. We actually have 84 individuals from 29 organizations. We got a new person yesterday who have early reviewer access, just to give us initial feedback about the model before we go through with public release. So these organizations range over private and public entities. So we're getting a lot of different use cases and feedback from a lot of different people. So we're planning for release December of this year. So it's available to the larger community so we can collect feedback. We want to do an independent release where we're not on attack.miter.org right now, just to help facilitate rapid response to feedback that we anticipate getting. And if you want access before that time, we are currently allowing that via NDA. So if you have any questions about that, please let me know. We're really excited to get this out to the public so that you can start using it, so that you can start providing your feedback, and we can mature and refine it. So I think I have time for questions.
We'll push questions into break.
Okay,
so we're
cool.
about to go there. Please join me in thanking Otis Alexander.